we use this one because it's got two parts. So A1V1 is equal to A2V2. So you want to calculate the area in your pipe at location 1, and you want to calculate the area in your pipe at location 2. And it's a pipe, so the area of a pipe is pi r squared. So you plug in your radiuses, so it was pi times radius squared and pi times radius squared. And then we get an area through the large section of the pipe that is equal to 0.0050 meters squared. And then at location 2, our area is 0.0013 meters squared. Okay. Now I'm writing down rounded values, but I'm hitting store in my calculator, and I'm going to keep every decimal that I can, because if we start using rounded answers, our answers are going to get further and further from what they should be accurately. But this and this are what are going to go here and here. So we already identified that this is flowing at 1.5 meters per second. So we use our numbers. And we get a velocity of 6 meters per second. Okay. Okay. So what happened to my radius was cut in half, but it's radius squared, so that reduces my area by a fourth. But if my flow rate is constant, if the area goes down by a fourth, that means my velocity has to increase by a factor of 4. So we went from 1.5 meters per second to 6 meters per second. Stick your finger over the end of the hose, it's going to squirt further because it's moving faster. Flow rate is equal to flow rate. I'd like you to try problem number 6. Similar, 6? I think it's 6. It's similar to problem number 5, but it's the opposite. So instead of my pipe getting smaller, my pipe gets larger. Now this one I wrote a little bit differently. And the reason I wrote it like that, I wrote it such that it talks about a 0.05 meter pipe. If water is flowing through a pipe that is 0.05 meters, that's the diameter. Now you can say, well, why did you give me the diameter? We need radius to determine area. And the reason is because if you go to Menards, you go to Ace, you go to the Home Depot, and you say, hey, I want a pipe. You say, well, how big a pipe do you want? I want a 2-inch pipe. And they give you a 2-inch pipe. But pipe is measured in diameter, not radius. So that's the idea of that. Is just to kind of, when we order things or we purchase pipe in the everyday world, we actually buy it by the diameter of the radius. So it's a 2-location problem. I would suggest drawing a picture and labeling it, and then use your 2-location problem equation. So give that one a try. We'll talk through it quickly, and I'll get you a worksheet to work on. So I drew a picture up here, and I have a diameter and a velocity, and a diameter and a velocity. That's what was given. I have to recognize the fact that I'm going to have to determine the area, which area is pi r squared, so I added radiuses in for each one, so half of my diameter is my radius, and half of my diameter is my radius. Pi times r squared gives me an area. Now this is a rounded value. I stored the number in my calculator. Pi times r squared gives me an area. That's a rounded number. I stored it in my calculator. Then I say A1 V1 equals A2 V2 because my flow rate here is equal to my flow rate here. So area times velocity is equal to area times velocity. So velocity is 0.47. Now, the calculations that we've done are either looking at flow rate, volume, time, what am I missing? Area, I think that's about it. In these two location problems, the two problems that we did, I've only asked you to solve for velocity. But there's no reason I couldn't say solve for area. I could say solve for A1 or I could solve for A2. And then if you solve for A1 or A2, I could then say, well, what's the radius of your pipe? Because if you know the area of a pipe and it's a circle, you could take your area, divide by pi, and take the square root, and you'd be left with r. So it'd just be another calculation that we could do, just for the record. We've gone the other way, where we go radius to area, area to flow rate, but we could go the other way. Just something to be aware of. So, in terms of flow rate, this is it for flow rate. It's pretty straightforward in terms of you just got to figure out like which flow rate equation are we using? Are we using the one with area and velocity, or are we using the one that has volume and time? Or is it a two-location problem where you use area and velocity at one location and set that equal to area and velocity at the second location? So on the top are some equations. They're also listed on your formula sheet. If you look, there's a couple, like number 4 on the back. The second question is crossed off in gallons, which also then should mean the in gallons answer should be crossed off. It's a unit conversion that I had them do at one point. I'm like, let's not do it. And I haven't deleted it because maybe I want to add it sometime, but I don't know. And then the same thing for number 5 is cubic meters per second. That cubic meters per second one should get, the answer should get crossed out too. Be mindful of units, especially like on number 4. There's some extra information. You got to kind of figure out which information you're using. But if you're going to go through and they give you a flow rate in meters per second, meters cubed per second, then you got to make sure that your volume would be in meters cubed, or that your time would be in seconds. You can't use meters per second, meters cubed per second, and then plug in hours or days. You got to have common units there, so be mindful of that. Yeah. So this is due in Canvas on Sunday. Officially on Sunday. My guess is if you're working on this, you'll get it pretty close to being wrapped up today before you walk out of here. And then any questions you have, let's make sure you get them answered, because this is really about it for flow rates. So.